Okay, everyone, let's go ahead and get started with the review. This is working on the test for rational exponents and radical functions. And I am going to go ahead and go through the entire review, okay? All right, for number 1 and number 2, we are looking for the real nth roots. Now, when it's asking us to find the real nth roots, that's when we need to consider both the plus and minus option when possible, okay? So let's go ahead and turn this first, or write it in radical form. So I will have the fourth root of 6,561. Now, a couple of things that we've talked about is that this is an odd number. So since it's an odd number here, okay, 1 is odd, we know that it is either going to be 3 times 3 times 3 times 3, or 5 times 5 times 5 times 5, or 7 times 7 times 7 times 7. And we considered those numbers because those numbers are also odd. And only an odd number times an odd number will give me an odd number, okay? So let's go ahead and look at those ones. And in this case, it is going to be plus or minus because it is an even, it is an even root. Even root is when we're going to consider the plus and minus option, okay? So this one here is going to be plus or minus, and the value of the fourth root of 6,561 is 9. So our answer here will be positive 9 and negative 9. Okay, you have to have both parts in order to get credit for that one. Okay, the next one, I'm going to take the fifth root of negative 1,024. Taking the odd root of a number, we keep the sign. So this one here is going to be negative 4. All right, let's go on to problems 3 and 4. Here we are going to evaluate the expression. This is without using technology. So this is the one where you can't use any calculator on this one. All right, so we are going to convert these into a radical. So converting into a radical, if I have a rational, which they give us on number 3 and 4, we are going to rewrite it as a radical. Then we will simplify the radical, the stuff that's underneath, or I'm sorry, within the parentheses. So we'll simplify that first, and then we'll take it to the power of m. Okay, so let's go ahead and do that. So we will have 625 is our radicand, 4 is the index or the root, and 3 is the power or the exponent. Okay. The fourth root of 625, that is 5. And then 5 to the third power, that is 125. All right, number 4. We have 512 is the radicand. The index or the root is 3. And the power or the exponent is negative 2. Okay, there's only one extra step to this one, so please don't see it as some brand new problem. It is just one more step. Do the same thing we did first. Find the cube root of the radical. So the cube root of 512 is 8. So we're going to have 8 to the negative 2 power. Now, if it was just 8 to the second power, that'd be 8 squared. That would be 64. But because it is a negative exponent, and we cannot have negative exponents, we are going to place 8 and then positive 2 in the denominator. Well, that means there has to be a 1 in the numerator. Okay. So we keep the 1 in the numerator. You cannot get rid of a 1 in the numerator. However, you can get rid of a 1 in the denominator, like we don't have to write it. You cannot leave it blank for the numerator. So 8 squared gives us 64. Okay, so what if it was, and I'm going to pick up a different color here. If it was 8 squared, then you would have just told me it's 64, okay? But because it's 8 to the negative 2 power, we have to write it 1 over 64. We have to move that term with the exponent to the denominator so that it's a positive 2, okay? All right, let's go on to number 5. Now on number 5, we are looking for the real solutions. Okay, so on this one here, we're going to go ahead and take the 4th root of that. And the reason that I'm taking the 4th root of that one is because, I'm taking the 4th root first instead of adding off the 8. I'm sorry, hold on just a second here. So I'm going to go ahead and take the 4th root because I cannot get into the parentheses without getting rid of what's outside of the parentheses first. So on that one there, we are going to take the 4th root. And whatever I do to one side, I have to do to the other. Okay, and on the right side, it's going to have plus or minus. So on the left side, the 4th power and the 4th root cancel out. So we are going to have x minus 8 is equal to plus or minus, and the 4th root of 256 is 4. Okay, I'm going to add 8 to this side, add 8 to this side, and remember I place them in front of the plus or minus. You don't have to, but it helps me just to organize that information. So we are then going to have x is equal to 8 plus 4 and 8 minus 4. So our solution on that one is going to be x equals 12 and x equals 4. All right, on number 6, on this one here, the cubed power, 3rd power, is only touching the x. So that 5 has nothing to do with it. I can go ahead and get rid of that 5. So we are going to divide 5 off of this side, divide 5 off of that side. That will leave me with x cubed is equal to negative 125. Okay, take the cube root of both sides, and I will be left with x equals negative 5. Okay. All right, let's go on to number 7 and 7 through 10. Here we are simplifying the expression. Okay, it's no decimal answers. So when we have a power to a power, so power on the inside and a power on the outside, this is when we multiply the exponents. So we will have 8 is our base. 3 times 1 gives me 3 in the numerator. 4 times 5 gives me 20. Okay, so 8 to the 3 over 20 power. Now, when you are writing this, do not write it like this. If you give me that, I will count that as wrong because that is 8 times 3/20. Okay, I am looking for 8 to the 3 over 20 power. Okay, on number 8, now we are multiplying the common base. So this has a base of x, this has a base of x, and I'm multiplying them together. So on this one here, we are going to add the exponents. So I'm going to have x to the 3/4 plus 1/8. Now before I can add the exponents, so anytime you're adding fractions, they have to have a common denominator. So I've got to multiply this one by 2 and multiply this one by 2 so that I have a denominator of 8. So that will give me x 6/8 plus 1/8. Now I can add the exponents. So I have x to the 7/8 power. All right, let's go to number 9. Well, when I'm multiplying the same bases, I add the multiplying the same base, I add the exponents. when I'm dividing the same base, I'm going to subtract the exponents. So I will have x 9/10 minus 2/10. When we're subtracting fractions, they also need to have a common denominator. This example already has a common denominator. So this one here, 9 minus 2 is 7. We keep the denominator, tenths. So x to the power of 7/10. Okay. All right, on number 10, we are simplifying this. We've got to take the fifth root of each of these pieces. Okay, so we are taking the fifth root of negative 32, taking the fifth root of a to the 12th, and the fifth root of c to the 35. All right, so to a power of 35. All right, let's go ahead and look at each of these pieces. Can we take the fifth root of negative 32? Yes, we can. The fifth root of negative 32 is negative 2. Can I take the fifth root of a to the 12th? Well, 12 cannot be divided by 5, but 10 can be divided by 5. I'm going to show this in a little bit of expanded form here. Okay, a to the 12th is like having, or is having, a times itself 12 times. Make sure I write enough of those. Let's see. Okay, so I'm looking for groups of 5. Every time I have a group of 5, I can take out one group. So here I have a group of 5. There's one group of 5. Here's another group of 5. And then I have 2 left over. So I have 2 groups. So I have a squared. Now these 2 a's that are left over, since they're not part of a group of 5, they're actually going to stay underneath the radical sign. Because you have to be a group of 5 to be able to get pulled out of there. Okay, so the shortcut to that we've talked about in class is we can take 12 and see if we can divide it by 5. Well, I can't divide 12 by 5 evenly, but I can divide 10 by 5. So 10 divided by 5 gives me 2, and that's where I get a squared from. And then there was still 2 of them remaining, so 10 minus 12 leaves me the 2 remaining, and so that a2, or a squared, has to stay underneath the radical. Okay. Now, if I'm looking at it and I said, okay, can I take the fifth root of c to the 35th power? Can we divide 35 divided by 5? Yes, that gives us c to the 7th. There's no c's left over, nothing more than 35, so I don't need any more c's underneath the radical. I'm going to give you one to try as well, okay? Try this one, and once you have it, feel free to send it to me and say, Miss Garrett, did I do this right? And I'll let you know, okay? So I have fourth root of 81, x to the 7th power, y to the 4th power, and z to the 8th power. All right, check that one, send it to me, and let me know what you get, okay? All right, so this is going to be a you try. All right, number 11. Now, these ones here, we're talking about graphing. Now, I want you to pay attention to whether it is a square root or a cube root, okay? When it's a square root, there's no value out here because it's an understood 2. You need to know that no number there means that it is a 2 out there, okay? So we're going to take the radicand, and we're going to set the radicand equal to 0, equal to 1, equal to 4, and equal to 9. All right, we're going to go ahead and isolate x. So we're going to subtract 6 on both sides so that we can get x by itself. Here, I'm going to have x equals negative 6. That's my first input value. Over here, I'm going to have x equals negative 5. Here, I'm going to have x equals negative 2. And on the last one, I will have x equals 3. All right, once we have those x values, we're going to plug them back into the function 4x. So I'm going to replace the x with these input values. So I'm going to do g of -6. That's the rule that's telling you what I'm doing. So I have the square root of -6 plus 6, and then plus 2 is outside of that. -6 plus 6 gives me the square root of 0, and I still have this plus 2. Square root of 0 is 0, and 0 plus 2 gives me 2 as the output. Okay, all right, let's do that again. This time, though, instead of putting in -6 for x, I'm going to put -5. This plus 2 is outside the radical. That is not part of the radicand. So then I have 1, then plus 2. The square root of 1 is 1, and 1 plus 2 is 2. Or 1 plus 2 is 3. That was a silly mistake there. 1 plus 2 is 3. All right, now let's do it again with -2. So -2 plus 6 plus 2. That gives me the square root of 4 plus 2. Square root of 4 is 2. 2 plus 2 gives me 4. Last input value that we're going to use is 3 plus 6. Plus 2 is outside of the radical sign. Square root of 9 plus 2, which is 3 plus 2. And that gives me 5. Okay, now I've got my table set up and I can go ahead and graph these points. So -6, +2. -5, +3. -2, +4, and 3, 5. All right, now remember our radical functions. This here is their starting point, okay? So that's where we're starting, and then it's going to shoot off to the right, go all the way through the coordinate plane, increasing at a very slow rate, but it's still increasing. It does not turn around to start decreasing. All right, now we're going to go ahead and look at the domain of this one. So on the domain, I'm looking at how far to the left did it go. So what was this value right here? How far to the left? And then how far to the right did it go? Well, it went to -5, -4, -3, -2, -1. It's going to keep going to the right for how far? How far off in that direction? Well, that arrow tells us that it's going to continue for an ever and ever, which is going to be positive infinity. So the domain began at -6, and it continues to positive infinity. Now the range does not look from the left to right. The range looks from the bottom up. So for that part, looking at how low this is when it started. Well, it started at +2, okay, and it goes to 3. So here it was 2, here it's 3, here it's 4, here it's 5, here it's 6, and it's going to continue to rise. So this one for the range from the bottom up, it is going to be starting at +2, put a bracket there because that's where it actually started, and it's going to go as high as positive infinity. Okay. Transformations. The +6 underneath the radical and in the radicand, that +6 is a horizontal shift. It's the only one that starts with H in our formula. So the horizontal shift makes it go left 6. That +2 outside of the radical, that's a vertical shift. This one here is going to go up 2. Now, end behavior. as x goes to positive infinity. So as x moves to the right, where is the y value going? The y value is constantly increasing. So the y value goes to positive infinity. Okay? All right, I am going to leave the one with the cube root for you to do the equations for, but I'm going to go ahead and fill in the table and the graph, but I'm not going to do the whole table on that, okay? So when you have this, though, you're going to take your radicand. So the radicand is x minus 2, and you're going to set the radicand equal to -8, -1, 0, 1, and 2. This time you're going to have 5 values that you're going to set it equal to. Okay? All right, when you simplify those, your x values will be -6, 1, 2, 3, and 10. Okay, when you plug it into the equation, when you plug it into this function right here, your outputs will be -5, -4, -3, -2, and -1. All right, let's go ahead and graph those points. So I have -6, -5. Then I've got 1, -4, 2, -3, 3, -2, and 10, -1. Okay. Now, when you're graphing this, make sure you go all the way to the coordinate plane. Know that this graph never, on the left side, it never turns to increasing. It's always decreasing at a very slow rate. On the right side for this graph, it's increasing at a very slow rate. It never goes to decreasing on that side. All right, so the domains for these ones go from -infinity to positive infinity. Arrows on both ends tell me it's going to go left and right forever and ever. The range, it's going to go down forever and ever, and it's going to go up. It's going to increase forever and ever. Okay, so they're both -infinity to positive infinity. Transformations, underneath in the radicand, it says x minus 2. That is the horizontal shift. This one here is going to go right 2. The -3 outside of the radical sign, that is the vertical shift, which says it is going to go down 3. Now, the parent function for this graph, okay, looks something similar to this. I'm just drawing a really quick sketch of it. Okay. Now, that one, between the pink one and the blue one, it went down 3 units from here to here. So it went down 1, 2, 3, and then it went right 2, 1, 2. Okay, so that's what we're looking for when you're looking at your graph. How did it move from the parent function to the new function? Went down 3 and right 2. Okay. All right, now that is it for that one. If you have any questions, feel free to reach out to me, and I will get back to you. All right, have a good night, guys.